Okay, team, hey, we are just finishing up the activity for 3.3 angles of polygons. So I'm going to finish this up real quick. You can see A through C. And I'm going to do what I call the clamshell method, which is what I did here. That helps me make sure I don't miss any triangles. So I'm going to start here and just go to every vertice. And I'm going to count the triangles. Well, there's a little one here, 180, 180, 180, 180, 180, 180. So it's a total of 1, 2, 3, 4, 5, 6 triangles, 6 times 180. Hey Siri, what's 6 times 180?
6 times 180 is 1080.
Oh, there we go. 1080. There we go. So going down to my table then, you should have a table that looks like this, okay? Now, this is kind of fun. It asks us to find the sum of the interior angle measures of a 12-sided shape. Very interesting. A 12-sided shape. We ended, our biggest shape was at 8 sides. Very, very interesting. Well, I could look for a pattern and just extend this table. I could absolutely do that. 9, 10, 11, 12. I could do that. And it turns out there is a pattern. I wonder if you can already see that. It looks like every time I add a side, I also add a number of triangles. And then along the bottom here, I'm going up by 180 every time. So there is a pattern that we can use to figure this out. 7, 8, 9, 10. And I can add 180 each time to get my answer, which now I feel like I really want to. 10 triangles is going to be 1,800 degrees. 1,800 degrees. In fact, let's do this. Erase. 1,800. Now, it turns out there's a sneaky formula that we can use to predict the interior angle measures of any polygon. It could be a 30-sided polygon. That'd be a lot of work to make a table that goes all the way out to 30. That's a lot of work, so a formula can be helpful. So I would challenge you to maybe pause the video and think about it, see if you can come up with a formula. I guess that's optional. I'm going to go ahead and show you how you get it, but if you want to take the time to figure it out yourself, I think that'd be pretty cool. But basically, the interior angle sum, I'm going to use S, is equal to the number of triangles times 180, right? Like, think about it. I got 1 times 180, 2 times 180, 3 times 180, 4 times 180. It's the number of triangles minus, or the number of triangles times 180. Now, the number of sides is just the number of triangles plus 2 each time, right? 3 plus 2 is 5, 4 plus 2 is 6, 5 plus 2 is 7. So we get this sneaky formula that we can use. We can say the sum is equal to the number of sides, which is n, minus 2 times 180. There's my sneaky formula. Sneaky formula. So let's say that I asked you to, whoa, what's going on? Uh-oh. Oh no, how do I fix that? Oh, darn. Great. Now I made a giant mess. Oh no. How do I fix this? Great. Barnacles, as SpongeBob would say. All right, I'm just going to press forward. So let's say I asked you about a 30-sided shape. To find the interior sum, I would use my formula right here. Sum equals n minus 2. Well, my n, that's just the number of sides. It's 30. 30 minus 2 times 180. 30 minus 2 is 28. 28 times 180. Hey, Siri, what's 28 times 180?
28 times 180 is 5,040.
5,040 would be the interior angle sum of a 30-sided shape. Okay, team, thanks for playing. More in the next video. This was a little bit messy. I'll do a clean example in the next video. Thanks, guys.